Hi everyone. I hope you guys are having wonderful weekend. So to help you guys have a wonderful weekend, I will try to make this video short. So this video we will look at problem 113 from Leetcode. This is just another variation of how to write a depth first search, but I don't think this problem is too difficult. So let's look at the problem. So here is the problem statement, and try to pause this video and come up with your own solution. Okay. Oh, and I want to emphasize that pay close attention that we have to have whatever our array is, we have to have root to leaf path. So that's the key part. So the bottom node must be a leaf node itself. So that's something that we have to keep in mind. And yeah, let's look at my solution. So this is our typical DFS approach, like DFS problem. Well, how do you write a DFS code? So typically we will be using recursion. If we are using recursion, then we have to think about the base case. Like in this case, it will be if the node is like none or null. If it is null, then we have to backtrack. And then the way we do that in Python is we return. We have statement called return, and then that's it. So if not node, then we return. So that's one way to deal with this kind of problem. And then the order here is either you can go visit the left child first, or you can visit right child first. Like order, like as long as order is consistent, I don't think it really matters. And either way you can do it. You can go visit left guy first, or the right guy first. Doesn't really matter. So here is my code for this problem. Well, so we have target sum is equal to 22, and here if the node is equal to none or null, if the node is none, then we backtrack. Then the way we do that is we have this return statement. Otherwise, we append the node's value. So in that case, it will be the integer. So we would have stack.append node.value. And then we check. If we are at the leaf node, we check. Well, actually, let me rephrase this. If the sum of stack so far is equal to target sum, then we also have to check if that node itself, if current node is equal to the leaf node. We do that by we check if node.left is equal to none and node.right is equal to none. If they are satisfied, so if these two conditions are satisfied, then all right. So this is we have a valid path from the node, root node, all the way to the leaf node. Okay, so then we would have to append that our stack to our answer. So we have to copy that, and then we append it to our answer array. And one thing that I want to emphasize is that, like, please do not forget about this copy function, or you can also say append, and then inside this parenthesis we have list of stack, something like this. So if you do not have those, either one of them, then like instead of this, if you have answer.append and then inside the parenthesis you just have stack, then you will not get the answer. What do you think you will get the answer if you just put stack here instead of stack.copy? If you can answer that, that means I think like how this one works. So if you are coming from C++ or C, you don't have to worry about this part, because you have to think about this before you write a code. But so that's something that I want to emphasize in this problem, is that you can make a very small mistake here, and then that could screw like your code, your answer. And then once we do that, we have to pop. Okay, otherwise we have to check its left child first, and then we do that by running DFS of node.left, and then we check the node.right, and then we have to pop. So let's look at how the order we traverse in this tree. So we will be at this is our root node, so this is the first position that we will visit. So we have one here, and then we will be since this condition is not satisfied, this if statement, we would have to look at the the like this else statement. Oh, and also I want to emphasize, I here wrote stack.pop here and the stack.pop here. Instead of doing this, you can also write stack.pop in here, like outside of this if and else statement. That one works, and I think that one is much cleaner. But so what made us, I think this one works, but the other approach is much cleaner. So yeah, so here we'll be running DFS of node, and then from DFS of node, well, these conditions are not satisfied. We have to run DFS of 4 and DFS of 8. So we'll be running DFS of 4, and then we'll be running DFS of 11. Say we are at DFS of 11, we would have to run DFS of 7 and 2, right? DFS of 2, because this sum is not equal to 22. So once we are at DFS of 7, we check if the left node and right node, well, so we will be running what? DFS of 7, and then here we will be looking at is left child. So we'll be running DFS of 7.left, and then when we run DFS of 7.left, we notice that this node is equal to none. So if that, in that case, we backtrack, and then we do that by return here, okay? And then so we are at here, and then so this part was 7.left, and then we have to run 7.right. So 7.right means this guy, and this node is also equal to none, so we backtrack. So we are at here, and then well, we have to pop this stack, because so far our stack was what? 5, 4, 11, and 7. 5 was at the bottom, 7 is on top. Now we are at here. We check both left and right child, and we notice that they are both equal to none. So that means we have to pop this 7. So 7 is popped. Our stack will be 5, 4, and 11. So 5 on the bottom, 11 on top. Now we would have to run DFS of 2 here, right? So DFS of 11. When we have DFS of 11, we would have to run DFS of 7 here, and then we would have to run DFS of 2. So once we run DFS of 2, we notice that, well, no, this is not true. This node is not equal to none. So we append this 2 into our stack. So our stack will be 5, 4, 11, and 2. And then we check if the sum is equal to 22. Well, yeah, the sum of stack is equal to the target sum, 22. And then the node, its node is left child, and then the right, its left child and right child are empty node. So that means this is the valid path from the root node all the way to the leaf node, and then the sum is equal to the target sum. Then we have to append that to our answer, and then we do that by stack.copy, or you can use list of stack, and then we have to pop this one. We have to pop 2, and we backtrack. So then we would have we had DFS of 4, then we had DFS of 11, and DFS of 4.right. 4.right is empty, it's nothing, so we backtrack, and then we have to pop this again. So we have 5 here, and then we have DFS of 5.right, that will be 8. So that's how you'll be traversing all this binary tree. So that's for that problem, and let's see the code. Alright, so that's the code for this problem, and as I mentioned before, let's try to change this, that we can have stack.pop. That one works, and let's see. So that's for this problem. I don't think this one was one thing that you have to keep in mind is just really pay close attention to this part. We have to copy the stack and then append it. If you have say stack itself, then we will not get the right answer. So yeah, so that's something that we have to keep in mind. And well, that is for this video. And if my video helps you guys understanding a little bit of DFS, then please give me thumbs up and subscribe to my YouTube channel. Thank you, and I will see you next time. Bye bye.